we still have 1 minute, and the room is only half full or half empty, depending on which side we look at from, optimistic or pessimistic. And I have a specific reason, somebody may guess why, but I would recommend that everybody moves forward if possible. Usually, when I was teaching at the university, I was also asking the students to do that. It was always the worst students sit back, so if I remembered at the end during the exams who was sitting in the back, that's not good. But now I have some specific reason. Now I don't need to shout because we have nice loudspeakers. 20 years ago at the uni we didn't have. And it's just time to start. So this presentation is about comparing Go language to Java and understanding Java value types. And when I was telling my friends that I was practicing, rehearsing this presentation at the company, and I said that I will talk about Go language in a Java conference, and they said, "You are a very brave man." Really? Why? And really, that's the most important thing that we should address before we get into the details of this presentation. I am a Java programmer. Why should I care? Go to Google's language. So what? Why should I care? And I tell you why I care. My story, that in 2015, I read an article about Java value types. And I have my background. I started programming in the late 70s when I was a kid. So I started with C language and assembly and things like that. So I understood what value types really are, but not all the details as I look back. That time I thought I understood them, but now I remember that I didn't understand them properly. Now I think I understand them properly what they are. Later on maybe this changes. But my major thing was that, okay, I read value types, I understand what they are, but why do we need them, so what? And then later on, I forgot it. It was not my major focus, and I was interested a little bit in Go language. And a year later, I learned a little bit to play around with Go. What this language is, it's interesting. People talk about that, and then I understood more or less how Go works, and then value types came into my attention again. And then when I read this other article about value types, then I remembered what I was reading in 2015 about Go, and then it was like an epiphany that, oh my God, now I understand it. Golang was helping me to understand what value types will be in Java and why they are needed and why they are so different and why all those things that I will discuss only the surface of it. I will just scratch the surface. But Golang was helping me, and therefore I thought it's nice and it's a good help if for the Java community I create this presentation and I talk a little bit about Go language and how it handles objects, and then it will be easier to understand what value types are. In addition, that Go language itself by its own right is a very interesting language, and even though we are all Java programmers, we shouldn't box ourselves, even out-box ourselves, into Java only. And Go is so much different. So if I can compare Python, Swift, C++, or other languages, how much we as Java programmers can learn from those languages, and then I look at Go, then I think Go is the one that is so different that it's outstanding, and that's the one that teaches us the most. And I dare say we understand Java itself much more if we understand Go. But before I get into the details, I would like to make a few disclaimers. The first one is that I'm not a Go programmer. I am a Java programmer. I do my living professionally, develop Java code. But as I mentioned, I started much before Java was started. So I'm a polyglot programmer. I can program a little bit in many other languages, in C, Fortran, Python, Perl, whatever, you name it. So Go is only one language that I'm not afraid of if I need to touch it, but it's not my major area of focus. But the most important disclaimer is that will somehow overcome all these disclaimers is that I came from Switzerland and I have Swiss chocolate. And I will ask you questions, and whenever I see an icon on the screen, it's mainly for me, to remind me that I have to ask the question. There are some rhetorical questions I will not ask, I don't want answers. But whenever I see an icon, then I want to ask you the questions, and if somebody gives a good answer, I will throw a chocolate. If you are lucky, I can hit you. So let's start with a question then. What is the answer to the ultimate question of life, the universe, and everything? That was the first one, 42, yes. Yep. I did it. So it's 42. I have another question, specially tailored for Mainz. Was ist die Antwort nach dem Leben, dem Universum und dem ganzen Rest? 42. I don't know who was saying it first. There? The lady? Thank you. What's the difference of the two answers? The order of the numbers. Why do we say it differently?
Because of the Arabic notation.
The funny thing is that I thought that Arabs read from right to left, and they read the letters from right to left, but no. The origin of the Arabic numbers come from India, and they really read from right to left, even the numbers, so they use the ones, the tenths, the hundreds, and so on. Arabs not. They read from right to left. At least one Arab guy told me that. And then they read the numbers from the big digits to the smaller digits. In ancient times, before the trading needed the numbers and the decimal notation, the numbers were read the other way around. At least, I mean, in every day, nobody was speaking about numbers larger than 100. So they were saying 2 and 40. And in Old English, it was 2 and 40. In Middle English, it still appears if you talk about somebody's age. And in modern English say 42. German, it remained. So it came around the 11th century to Europe and later on into Germany. And there was a debate how it should be said, 42 or 2 and 40, as in German. And in German language, it remained. The question is, which is the better? The thing is, it's a rhetorical question. I don't want answers because then we don't finish within an hour. The important thing is that it's a question like riding on the left side of the road or the right side of the road. It doesn't really matter. The only thing that matters that within one country, everybody does the same. It's okay that in England they ride on the left side. It's okay that in Europe we ride on the right side. We shouldn't mix it within one area. Okay, so this was just a little warm-up, but it's related to what I want to talk about, and let's focus on the main area then. So Go language is the language of Google. And what is Go language? Let's start now. Some people say that Go is the new C++. Okay, kind of. Or C++ done right. Google says that Go is a system programming language. Well, they wanted to do that the way like that, so it is. We should accept that, and I can agree with that. Many people say that Go is genius. Well, I can understand that. Many people say that Go is terrible. The interesting thing is that the two set of the people who say this is genius and this is terrible are not disjunct. There are some people who say that it's genius and it's terrible. I tend to agree with them. But seriously, Go, for a Java programmer, what should we know about Go? That Go is a compiled language. It compiles to an exe directly. There is no VM. It's object-oriented and functional. There is a garbage collector, but it's not a garbage collector, or is it a garbage collector? If you tell the Go people that this is not a garbage collector, you will get into trouble. So don't tell that on a Go conference, okay? You may not leave intact the conference. So, what I will talk about is the language syntax, about exceptions, garbage collection, local variables and stack, closures, routines, and object orientation and inheritance, which there is or there is not. There is a debate about that. There is something, whether we call it object orientation or we don't call it, is a different story. But it's again something that debating about terminology is useless. If you understand what it is really, then you are okay. And I just focus on the things that I will not teach you Go. I will focus on the things that are important or interesting for a Java programmer. And I will only touch slightly the language syntax and exception handling and things like that, because I will want to focus on object orientation, how objects are represented in memory, because that's the thing that will teach us the most about value types. So, let's start the work with the syntax. It's mostly a C-like syntax, like Java, C#, Perl, perhaps Python. No, Python is not C-type. But there are some differences. Go language is designed in the syntax not to use characters which are not needed. So every extra character that you don't need is just noise. So if I look at this if statement and I say that I demand the curly braces around the block, which actually from the C-type languages, Perl is the only one that demands. All of the languages have the dangling else problem. So it's better, like Go demands that you have the curly braces. But if I have the curly braces, then which is the character which is not needed? The normal parenthesis, yes. You have a sharpie.
I'm Swiss, so I can give it to someone else.
Okay. So we don't need the parenthesis in Go. Okay. For example, if Z is 42, then the answer is 42. But in this case, it just prints out the answer is answer. When you declare a variable, Go designers said that all the C-type languages, it's just a weird that I say the type and then the name of the variable. It's much better if I write the type and write the name of the variable and after that the type. Anybody recalling this syntax? This is not Go yet. Anybody recalling this syntax? Pascal, yeah. Somebody there. You decide who deserves a few more. It's Pascal. But again, there is an extra character we don't need. Yes? We don't need the colon. Why? There's a name, there's a type. We write there a space anyway, so we don't need the colon. Okay. And we also can have an expression assigned to the variable, an initial value. But an expression has two things, not only a value. It also has a type. And this type can be inherited by the variable. So if I initialize a variable, I may not need to explicitly define the type if I am okay with the type, what can be deducted from the expression. So in that case, I can write just this. But it's so common that we declare variables this way that in Go language, this is valid, there is an abbreviation for that. And then we just get back that column that we saved up from the normal declaration. So when you see this one, and it again looks a little bit Pascal, it says that x is declared, gets an initial value, and the type is what is deducted from the expression. Again, if you look at the z variable, is a string which is declared as a string and gets immediately a value. But also, Go is very strict, and if you declare a variable which is not used, then it's an error. There are other things, like importing a package that you don't need, that's an error. There are many things that in Java, syntax analyzer or style analyzer will report. In Golang, many of these things are programming compilation errors. And also because Go doesn't like the extra characters, they say that in most cases that semicolon is just noise. So in most cases you don't need to use the semicolon at the end of the line. They will insert it for that. Actually they do it with a preprocessor. And because they also do not like extra characters and extra keywords, they say that in Java using lowercase letters and camel case is a convention. In Go, if you have a field variable or a function which is capitalized, that's public, everything else is private. It was freaking me out first. You can get used to it. It was almost freaking me out like the tabulation of Python. That's very strange, but it's logical. You just have to get used to it. And you shouldn't judge a language just because on things like that. Function. There are functions in Go and no methods. These are functions. And methods are also functions, but they have a receiver. Actually, today I've learned during a presentation here that Java 8 also introduced receiver as a terminology since Java 8. For some reason I wouldn't go into that, but I thought that it was only Go. Maybe they took it from Go. And whenever we declare a function, we just separate the different parts of the declaration with spaces and parentheses. We don't use colon, semicolon, or anything else. I will give you some examples. So, I have a function named myFunction that has an int argument. And it prints out. It's fairly simple, is it? Okay. Next example is I have a structure, which we will talk about very detailed in the object orientation part, which has a field inside, and the function named myFunction has a receiver, which is a pointer to my struct type and doesn't have any argument. So it's a method, but it's defined outside of the structure. Now it gets a little bit complicated. I have a function named myFunction that has an argument which is int, and it returns two values. So Go functions can return multiple values like Python methods, and usually Go functions return two values. They can return many values, but they usually return two values, usually a return value and an error state. Whoops. Now, my function has a receiver, so it works on a pointer to my struct, and it returns a function. Functions are first-class citizens in Go. They can be returned. Exception handling. In Go, there is no exception handling. When there is a problem, you have to return multiple values, an error value, and the caller is responsible to check the error condition, the error state, and you have to act upon that. But there is panic, which works technically exactly the same as Java throwable. What's that? It's not me. It's not me. I switched off and it's still coming. Sorry. So, panic technically works exactly like Java throwable, but it shouldn't be used like Java exception. The Go tutorials and documentation say that it should be used like Java errors. So something that you cannot really recover from. You should use it only if there is something really serious that you cannot handle. And there is no finally, but there is a differ. And it's very interesting because the differ statement has one argument. And in this example, I open a file. If the file is opened nicely, then I want to close it sometimes later. So I say differ fclose to the end of the function. Because there is no point to differ it to the end of some block inside the function, because if I needed that, then my function is just too long. I have to refactor it and have multiple functions, split up into several functions. Garbage collection, very interesting point. For the programmer, if you are a Go programmer, then there is an automated garbage collector. You allocate some array, or you have a new memory, a new value for a variable, and then it's allocated and you don't care about the releasing of it. If you are a hardcore GVM guy, then you should know that, no, this is not a real garbage collector. There is no compacting in it. And it very much depends on how the objects are stored and managed in the memory. Because there are pointers. And if I'm compacting the memory and I move an object from somewhere, there are no object structures. So I move something that has a pointer to it and I move it somewhere else, the pointer becomes invalid. Then I have to keep track of all the pointers, and then these are then not pointers anymore, then these are references. And that's very time consuming, and Go decided to go that way, that they don't do compacting and they don't move memory objects or whatever we call it. Okay, next question. Very interesting in Go language. What happens when you return a pointer from a function to a local variable in C language?
Segmentation error.
Sorry? Segmentation error. Yes. Sorry. Just give another one. Somebody gets an extra. No? Okay. Because the local variables are allocated on the stack. And I have a pointer that points here. The value of the pointer I return. But then when I return, the stack pointer moves up. And this area is a free memory. So I will have a pointer that points to some free memory. And it's invalid. And in C language, it's not recognized immediately. But later on, when the call stack goes down and somebody messes up the memory there, it causes some trouble, and then we get some core dump failed, and then some mysterious error that's very difficult to debug. What happens when you return a pointer to a local variable in Go? Is there somebody who knows Go?
It doesn't compile?
It does. No, it does compile. I say you chocolate. The thing is that Go does an escape analysis, and it realizes that, hey, this variable is escaping from the scope of the function. I have to allocate it on the heap. So, when you do something like that, it's very easy to allocate memory. I just return a new record, which would be a local variable, and then that's it. You can define a function inside another function, and you can return it. And the surrounding function is a closure. So you can program in a functional programming way. Just, sorry, yes? Hello? You still hear me? Yes. Great, okay. And you can return a function as a result. So Go is totally functional. For example, very simple example, we have a counter factory which has an argument j, an integer. Then we define a local variable I which inherits the type of j, so it's also an int, and its value is 13 in the example when we invoke this counter factory. And then it returns a function that increments I and then returns the value. So if I run this program, then it will print 14, 15, 16. And if I invoke counter factory again, then I will get back a different function, the same function with a different closure. So I can have two different counters in this case. Goroutines are very powerful and very interesting things, because when I tried them, I thought that they are threats, and I was trying to kill my machine starting up 10,000 of them. And starting 10,000 threads even on this machine doesn't really work. And it was just working. And then I had to learn that goroutines are not threads, they are fibers. Does anyone know what fiber is? No? Lightweight threads? Okay. When I have a thread and there is a context switching, so the processor has to execute another thread, then the context of the thread had to be saved somewhere, usually into the memory. So all the registers are put into the memory, which is at least 20-30 nanoseconds. The context of the other thread, which is going to run, comes into the register, and then the other thread runs. With lightweight threads, it's a little bit different. Lightweight thread should be supported by the compiler. The thread runs, and then there is a yield, which is a compiled code, something that the compiler generates. And at that point, the compiler knows what registers, what cache, whatever the processor is using. And for example, it knows that it uses only these 3 registers, and then the other registers are not used by any other goroutine or fiber, and it can save the state within the processor, or it needs to save only just part of it. The thing is that it can optimize the context switching. It's much faster. It doesn't need kernel code. And therefore, with fibers, you can run much more fibers than threads. But the compiler has to support it. But it's very fast. And if it's supported by channels, which is channel is just a queue, a first in, first out queue. And then goroutines usually deliver a programming paradigm that you start the different goroutines that work independently on processors, on processor cores, or on the same processor core. You do not care. It's up to the compiler and the runtime. And then you just send them objects. And the other goroutine just fetches the objects from the FIFO. And it's a very easy, kind of lock-free concurrent programming model. Therefore, there is also a Java initiative, a project to implement fibers. And there are some libraries that try to implement fibers or do implement. I've never tried them. Yes?
Are there any disadvantages of fibers related to threads? Because otherwise we will need threads.
Yes, of course. You need compiler support.
Okay.
If the compiler does not support on compilation time fibers, you cannot have fibers. And since the Java compiler currently does not support, the libraries have to do some neat tricks with the, I think, with the just-in-time compiler and the bytecode. Sorry, we shouldn't get into the details because of time and because of my lack of knowledge. I'm not really that experienced in that. And now, the major part that we will talk about the rest of this presentation, the important part. You now have a kind of feeling of Go, how weird it is. Now we will see how genius it is. The very first thing is that there is an interface in Go. But if you start to learn Go, then my advice is that when you get to the description of interface, stop your mind first and then program it so that you replace this word with something else. Call it abracadabra or call it whatever you want, because we have into our brain, we have carved into our brain what an interface is because of 20 years of Java. And it's something totally different. And it's very confusing. It took me 2 days until I understood that interface is not something like in Java. It's something totally different. And I try to explain you to save you these 2 days. So, you have an interface, you can declare an interface, and obviously in an interface you declare what functions something that implements that interface should have. But when you define a structure, you don't say that it implements that interface. After all, why do you need to say that it implements that interface? It either does or does not. The compiler will see it. If there are all the functions, then it implements that interface. If there is one missing, then it doesn't implement that interface. And there is a struct type, as we have already seen, examples of that. And a struct cannot extend other structs. So there is, that's why they say that's not object-oriented. But it can contain other structs. And containment and extension are just two relations between different types. And they are more or less equivalent. And that they are more or less equivalent you can understand with Go language. It demonstrates it very nicely. Because when I have a structure which contains another structure, and this structure, which is inside my structure, has a function which works on this as a receiver. It's not implemented in it, so it doesn't. When I say it has a function, it's a little bit sloppy, and I want to invoke this function on my encapsulating big structure. Then I don't need to say that I have this structure that has a field which is of type of that, and I want to invoke it on that one. It works like if it inherited that function, because it's fairly obvious. If I have only one path to that function, then it will be invoked on that contained structure. So it really looks like inheritance and polymorphism, but it's not. It's containment. In this sense, there is polymorphism with interfaces, but it's containment and not extension. And when functions operate on a certain type, then you can have this mimicked inheritance, and even there are multiple inheritance, unlike in Java. And if I contain more different structs, each implement, they don't implement, sorry, they have different functions, I can invoke each of them. If two of them just have the same name and same arguments and whatever, then it's a compiler error. Then I can and I should specify which one I want to invoke. It's something similar to C++. But until then, I don't need. So if I want to compare, before we go into more details, I want to compare objects in Go and objects in Java. We have interface. Yes, we have interface, which we define. Structures. A structure does not implement explicitly an interface. A structure does not extend another structure it contains, but a class implements an interface and the class extends other class. A function can work on a structure type, which is the receiver of the function. In Java, the methods are inside the class. And when we have variables in Go, the type of the variable is either a structure, which is a defined type, or the type of the variable can be an interface. And the major difference is that in Java, we have this distinction, but it doesn't really matter, because they are treated in JVM level very similarly or just the same. And this is the major difference. And why it's implemented that way, we will see that. Don't worry if you do not understand that it's very complex, and I get to there gradually. That's because in Golang, the objects are headless. In Java, when I have an object in memory, I have 8 or 16 bytes of header in front of each object. Depends on whether it's 32-bit or 64-bit implementation. So when I have an int, which is 4 bytes, I still have at least 8 bytes extra for every integer. And I also have in the header a multi-thread lock, which seemed to be a nice idea by the time it was designed, but I think we can agree that it was not really good, but we have to live with it. And it's very similar that we are riding on the right side of the road, and some people think that it was not a good idea, left side would be better, but we have to live with it, and it would be very costly to change it these days, just like with Java. But Go has a struct, and it has no header. It doesn't need. And when I have an array, for example, in Java, then I actually have an array of references. And the objects are here and there, somewhere in the memory that it points to. In Golang, I have an array of structs, and these structs are one after the other in the memory. Or if I really want to make it wrong way, then I can have an array of pointers or interface, and then it's an array of references. The variables that are of struct type hold the value. And the compiler knows the type. So, because if you declared it to be of a type, then it's that type. You cannot assign something that is extension of that, because there is no extension. A struct just can contain something else. When I have a variable which is a pointer to a struct type, then the compiler knows the type it points to, and it knows where the different fields in the structure start, and it knows how big it is, so it doesn't need the header. But variables that are interface type, they can reference just any type of struct that implements that interface. And in that case, the compiler does not know that at a certain point of time, that variable is referencing that structure or that structure or that structure. If all those structures implement that interface, then the variable can reference any of them. But the time when the reference is assigned to this variable, it should come from another interface variable or some expression, but we know the structure during runtime, and we can store it into the variable. So this is the trick. An interface variable in Go has two different values. The structure, or the reference to it, pointer, and also the type of the structure. So the header information, whatever the header is not attached to the object. It's kind of attached to the variable itself, if it's an interface variable, and it's compile time known if it's a struct variable. This is a very important thing to understand, how Go is handling object. This is the most difficult to understand without the help. At least for me, it was very difficult to comprehend this. And to carve it into your brain or burn it into your brain, as Java programmers, I have a very weird example. I will invoke a Go function on a null pointer. And it works. In this example, I have a structure which is empty. I have an interface, and every structure that has the my function implements implicitly this interface. And this my function is implemented for the my structure, and it just prints out receiver is and s is the variable for the structure. And I declare a variable in the function main on line 12, and I'm not using an abbreviation in this case because I want to declare it explicitly to be interface type, and I don't want to just inherit the structure type. And then I explicitly cast a nil. Again, Go is saving one character from null. They call it nil. It's also very common in other languages like Lisp. I cast it to a pointer to my structure, and then I invoke it. And because x is an interface type, and when I invoke my function, it knows what structure it refers to, even though the value itself, the pointer, is nil. It will invoke the my function, and this will print out receiver is nil. Funny, is it? Not trivial. And now something completely different. After we have learned Go, let's go to Java value types. And now you will, at the end of the presentation, just realize that, come on, I have already told you what value types really are, because in Go they are already implemented. But in Java, we will see them. So what are value types in Java? Who knows that? Come on, I have a lot of chocolates here and I have a slight diabetes, so I shouldn't eat them. Don't be so hard to me. Don't ruin my health. Come on. Yes?
We're going to just declare them with a var keyword and don't really specify what type it is, but it is known by the constructor or the factory method.
No, it's not that. That's just type inference. I give you chocolate because I'm mad, but it's not. Sorry? Yeah, you say that they are immutable. Yeah, they may be immutable, maybe not. But it's, we will know whether they are immutable or not when they come, really. But it's a good thing. It's something important that you were saying. Okay, so value types are things that were started in Project Valhalla in 2014. And already we have value types in Java because, for example, byte, short, int, long float, double, char, and boolean are value types. So these are some things that are not objects, but values. And that they are immutable, it's very evident in this case, because when I say that I have an int which is 3, can I change the value of 3? No. 3 is 3. And even tomorrow it's going to be 3, and even if everybody dies and the earth blows up and all the sun and the universe, 3 is going to be 3 even then, because it's mathematics. So 3 itself is immutable. But Project Valhalla aims that we could have user-defined value types. For example, something that has 2 double in it, and we can call it complex. And the aim is that they will hold the value, and they are not objects. And they don't hold reference, the variables will hold the object and not a reference to something. So if I compare Golang structs and Java value types, then I can say that objects have object header, interface in Golang have something like object header and the struct, the value, and Java will have something very similar to Go struct, which is a value type. Why do we need that? Yes?
I think for performance issues, so if you put a lot of them in an array, values will have pointers if you use classes.
Yes, very good.
You have them in
Performance issues, yes. Anything else? Yes?
Because when you do like file formats or hardware communication, you often don't want the object overhead. Like
Object overhead. Yes, I've already gave a hint about that when I was saying about how big, objects are. For example, if I have a date, in Java, I usually don't have date. I'm 28 years old, married, so maybe my wife, we go to opera. So I have a date, Java till date, then it's just a timestamp. And I still have 16 bytes header for that. Because perhaps sometimes somebody may want to access a date concurrently. No, concurrent date, that's weird, no. So they are good candidates for value types. Synchronization lock support, we don't need that really. Very rarely need. So value types will not have this concurrent lock. And also the objects occupy the heap. And value types, they are usually small things. They will be allocated on the stack. Come on. Nobody challenges this statement. It's a trap. Oh my God. I see that everybody is working in Switzerland in huge corporates, banks, financial institutions, and you are still using Java 1.6. Nobody is using Java 1.8. Java 1.8 introduced escape analysis of methods, and if a local variable references an object, creates a new object is created inside a method, and it's not too big, and it doesn't escape from the method, then the Java compiler will generate code that allocates that object on the stack, offloading the garbage collection, because it will not live any longer. I thought that somebody will challenge this. And again, what our colleague said very cleverly, value type arrays are CPU cache friendly. So when I'm working with huge data and I am working with an array, then I usually work with an array taking the first element, then the second and the third and so on. So we work on them usually sequentially. And the processor loads a huger chunk into the processor cache from memory. And then when I'm wanting to access the second element of the array, it's already there in the processor cache. If it's just a reference to an object, then I access the first element, then it's a reference. Okay, then I have to go to the memory, fetch the object. Okay, it's there. Then I want to access the second one. If I was lucky and the second object is very close to the first one, it was grabbed together, optimized into the processor cache, then I was lucky. And there are some optimizations that try to do that. But if I'm not lucky, then the second element, which is just a reference, is already in the cache, but I have to travel again to the memory and fetch it back. You know, the time to access the cache and to access the memory can be 10 times slower, approximately 10 to 20 times slower to go to the memory. If I have value types, then the array is there in the memory. I read the first half of the array, I work on them, then the cache habits, then I read the next element, the rest of the array comes into the cache, and so on. It's much faster. But generally, if I want to say something about value types on a high level, then the saying is that it codes, when we code it, like a class, but it works like an int. What are the consequences for the programming? Consequences that, for example, we can compare them with the equal sign, because these are not references, which if I compare with the two objects with the equal sign, I compare if the references are the same. The bits of the references are compared so that they are equal if they point to the same object. If I have two value types, then there is no difference between equals and the two equal sign. They cannot be null. Obviously, an int or a byte cannot be null, not the object, the primitive. If there is no value, even then it's 0 or false or something initial value. Because of the problem with polymorphism and because we don't have the header, there will be no inheritance. Or maybe there will be some inheritance to ease our life, but even then definitely there will not be any polymorphism. As in Go, there is no polymorphism in this sense. There is something mimicked polymorphism. And yes, if you can program, you can create structs that have fields which are function types, and then you can build up runtime inherited, even like in JavaScript, things in a functional way, and then there is polymorphism, but that's not the Go style. So we cannot have polymorphism with that. And when we pass value type to a method, then it will be passed by value and not passed by reference. There is a debate about because Java passes everything by value. Yes, even the reference is passed by value, but honestly, when we pass an object to a method, then we pass the reference to the object. But the variable itself is passed by value because the variable is holding the reference. So in that sense, it's passed by value. What are the consequences for the JVM? Well, it's not only Java. The consequences reach far beyond Java language itself, because there are many languages for the JVM. And for example, Scala has a value type. Don't ask me, I don't program in Scala at all, but I've read it that It has a value type, but it has only one field. It's limited, of course, because otherwise it cannot be implemented effectively on the GVM as it is now. But if we will have value types, then it will handle more fields. If we have value types, then languages like Swift and Golang can be more effectively compiled to GVM, or not, because they may need other things which I don't see right now, but there are many things. But it's definitely value type is something that they need. If we don't have value types, we shouldn't expect any Swift compiler that targets the Java virtual machine. And in many cases, not all cases, but in many cases, we can stop joking around with shared memory, memory mapped files storage, which is off-heap stored, to speed up the working of the programs. So many times, high-performance applications just do not allocate arrays of objects because of the CPU caching problem. They allocate some memory mapped file and then they access the bytes and they program it very low level, because that's even faster than always going to the memory and fetching the objects into the processor cache. In some cases, this cannot be saved. There are some examples where value types will not solve this problem, but in many cases, value types can solve this problem, and we can use value types for high-performance applications. So, if you remember how we started, 42, 2 and 40, where is the object header? Which is the better? Question, why? And which is the better? And now, there is a chocolate sign. It's not crossed. If you have opinion about that, we can discuss it. But before that, I would say that what's the takeaway of this whole story? First of all, it's a Java conference, so I should tell you and calm you, don't worry, Java is good as it is. And don't worry about the future, because, and it will be better with the value types in the future. And I can tell you that Java will always be better, and how you interpret it, that it will always be better by time, or it will always be better than anything else, is up to you. But learning Go, it's very easy. After all, you can go play Golang.org, and then just you can write very simple Go programs. It's compiled and runs on the web page. So you have a text field, and then you just edit and then hit run, and it works. And if you learn Go a little bit, then you may start to hate Java, but you wouldn't mind that. So at that point, you will just be happy. But if that doesn't happen, it will make you a better Java programmer. Thank you very much.